What is this, Lady Ada?
We're on air. Welcome to our Wednesday hangout. We do this every Wednesday at 7:30 p.m. where we share and show and tell all the cool stuff that people are making and showing off. It's me, Lady Ada, with me, Mr. Lady Ada. But this is your half hour to shine. We're going to call on people, unmute your mic when we call on you, show off your project 2 minutes or so, and we'll be out of here at 7:50. Starting off with Noe and Pedro.
Hello, everybody.
Hey,
Happy Wednesday.
Today's project is super relevant with all the talking the news with Facebook stealing your data.
Yes.
PT thought it'd be a good idea to have a little webcam cover because it wouldn't be even a surprise if it came out that they were spying on you with their webcam. So get a little Lego compatible camera cover with a Lego compatible Ada bot. You can go along with that. So super simple. All it does is just slide onto either your laptop or your iMac or whatever display that you have on your computer. Super easy to modify. It's all parametric. And of course, all of the parts for AdaBot are all easily swappable and compatible with the minifigs. So it's dual extruded. We're using 100 microns to get all that fine little detail on there. And if I can focus on that.
Yeah, this is the only bot that should be, they have all the bots, the Cambridge Analytic bots or whatever.
Exactly.
The only bot you should put on your laptop.
Yeah, this minifig is amazing. The quality, I mean, it's like it's perfect quality, and it's actuated and everything.
Yeah, and it's all
it's a
compatible.
good one-to-one scale, yeah.
And of course, you can have them all hang out with all the other popular robots as well.
Yay.
You can make a little scene on your desktop. Of course, have it protect you and decorate your workspace. So
Your privacy.
protect your privacy as well.
All right.
I know I did a whole layer by layer on making the Lego compatible, so you can make it all user parameters. You can adjust the size of how many studs you want, and super easy to modify. Check out the layer by layer, and of course, we talked about it for a whole hour on 3D Hangouts earlier today.
And may or may not have spilled coffee.
All right. Well, watch to find out the full conclusion.
Yeah.
All right.
Good look on the Stargate you're working on in the back. All right.
Oh,
What's up, JP?
Hey everyone, how you doing? I just wanted to show something I worked on last week on my show and tell, which was based on this AdaBox 007 project, which is a Gemma password vault. So this has 3 passwords on it, and you plug it into USB on your computer. When you want to enter a password, you touch one of the capacitive touch pads, and this uses the HID USB CircuitPython library to type for you. So rather than have this version, which would be kind of maybe when you put on your keychain and carry around with you, I wanted to make a desktop version so that when I wanted to enter a particular password, I could just reach over and touch a secret object on my desk. So I went to the thrift shop, and for $4.99 plus tax, I got this Tiki statue. And I embedded in its base using a Forstner bit and a drill. I drilled in there and made a 1 1/4 inch hole to fit a Gemma in there. And then I drilled out a hole for my USB cable so I can plug that in and out. And then I have one wire running up the back of the Tiki head to some copper tape. And now when I actually reach in, I don't even need to touch. It's capacitive, so I don't even need to touch it. The antenna is sensitive enough that if I touch his teeth, it triggers that one password to enter for me. So I had some problems running the 3 of them because of capacitive interference. So I haven't had a chance to look into that yet to see if I could do 3 antennas. This can be a tricky thing with wires running next to each other. But it's still a pretty fun project, and one idea on embedding your secret Gemma stuff into a sneaky object. And I'll use that as a segue and a plug for next Tuesday at 9 p.m. Eastern Standard Time. I'll be doing an unboxing of AdaBox 007, the Spy Edition. So hopefully a lot of you have gotten those in the mail already. And we'll be going through part by part and checking out all the cool stuff. So please tune in for that. And I'll be on tomorrow, John Park's workshop, at the usual time, 4 p.m. Eastern.
And next week we're gonna be away, so you're gonna be doing your show during the Wednesday night slot too. So
that's right. There'll be a special weird time slot edition of JP's workshop on Wednesday. So I'll do a blog post about that. So
Like on CNN, they're like filling in.
I'll send you out the pink wig, and if you grow a beard and with gray hair,
You can be both of us.
Yeah,
yeah, pink and beard.
that'll
Working
be
on it.
okay. All right. Next, we're gonna go to Ian. Hello, Ian.
Unmute your mic. Show off your epic beard.
Yeah, he's gonna.
Yeah,
Epic.
right on. Hey, so this week I thought I would show off a project that is 10 months in the making. I'm calling it Gorilla Clock, and it is a project that sort of ties in everything, Raspberry Pi Zero, soldering Python, although not CircuitPython, 3D designing and printing, and then a little soldering and wiring to go along with it. So this is it behind me, this little box right here. This is a custom built enclosure around your 16 by 32 RGB matrix. And I've got most of the project details up on Hackaday. So I'll just pull that up real quick because I'm having a little trouble getting the web interface to load for this. But if I can log in here, I should be able to kick this off for you. Here we go. All right. We're starting it, and there we go.
Ooh.
So what this does is it queries the New York City MTA bus API, bus clock time API. And then what it does is it displays whether or not there's a new bus in the route. And then it also displays arrival time. So it looks like it's glitching out right now. Might have some coding that I still have to work out. But if you want to come back later, I might have it scrolling in the back.
And it's just like the MTA, right?
Have it default to late because it'll be like right most of the time.
Yeah, here you go. No buses en route. Big surprise there.
It's working.
All right. Well, nice work. That was a beautiful case.
Okay.
All right, thanks, guys.
Well, the only thing it's missing is as seen on the show and tell sticker. So email support@adafruit.com. That'll go right there. That'll be perfect.
Yeah, indeed.
Okay.
All right, thanks a lot.
All right. Next up, we're going to go to, we have two Chris's. So I'm going to go to Christopher.
Christopher
first.
with the white hat.
Yeah. And then we'll go to Chris. Hello, Christopher.
The top hat.
I know what that is. All right, Christopher, unmute your mic and show us your, I bet it's Blinky hat.
Looks like a blinky hat.
Yeah. I think your mic is still muted, Christopher, but you can do maker charades. I have a feeling this will still work.
It looks like maybe there's like an iPad that
Yeah.
controls it.
Yeah, he has a device. It's a slab of glass.
Okay.
And he's going to connect up.
Okay.
Oh,
No, don't look at the password. Don't look at the password.
We can hack it. Okay. Now he's going to turn on, he's going to connect to, oh,
Maybe
there
it's
you
like
go.
an ESP266 or something, and then like it's on the hat.
Oh,
Ooh,
look at this, pack hat.
this is a pretty intense hat.
Yeah. You do not need to describe
This is amazing.
This is exactly what it is. Oh, wow. And so it looks like they're playing Pac Man on your hat and you're controlling it.
And there's
with
multiple
iOS.
animations.
Yeah, you're like,
So you can do like Starscape.
Yeah.
You can have like
This
the
is more
time or something. Or
yeah, it could be the score. And then this might be
Game of Life. Oh no, sorry, it's Space Invader.
Oh, Space Invader hat, yeah. All right.
Yeah, that's pretty cool.
And you have some,
This is great for weddings, by the way.
Yeah. Or the DMV. Works in both places. Ooh, look at
Brightness
that.
control.
Yep.
This is
Oh,
a
this
pretty
is
sweet
great.
hat. Nice hat.
Good,
Well,
good work, Christopher. Well, you can get a scene on the show and tell sticker for this. Email support@adafruit.com and it can go inside the hat, outside the hat. Good work.
nice. See, you don't need
Okay.
audio. We know exactly what's going on.
All right, I'm gonna go in Chris order here. Chris, you're
Okay,
next.
second Chris.
Hello, can you guys hear me?
Yeah.
All right, so originally I was planning on showing a different project, but it's not quite where I wanted it to be. And then I ended up doing this fun little one-day build that you can see here. And you'll recognize a rather large component on there. And I'm teaching a lab that we're covering transistors right now. So I wanted a demo for my students to show, well, what did we replace with transistors?
Okay.
And in their lab, they build a transistor nightlight. So just, single transistor, a photoresistor, and an LED. And so I replicated a version of that circuit using a vacuum tube. And let's see, let me pull this up so I can see myself. All right, there you go. So you have turned out to work better with two photo resistors. And as you can see, if I cover those, LEDs turn on, LEDs turn off. I have a boost converter getting 30 volts going to the vacuum tube, and then an LN317 giving 6.3 volts to go to the heater filament for the cathode. So just a fun little circuit that I can leave in my lab for students to get a little experience of past technology.
Good stuff. I like that you labeled it too.
I have a little write-up on it. I'll throw a link in the Discord if anybody's interested in the circuit.
Oh, okay, great. And like all the other projects so far, there's plenty of room for as seen on Show and Tell sticker. So drop us a note to support at Adafruit.com.
Retro nightlight.
Yep.
Love it.
Okay. Next, we're going to go to, we have another Chris. We're going to go to Chris.
No, that's the same Chris.
Oh, that's another. Okay, sorry. Sorry, Curtis. I'm going to get to throw out the C's. Hey, Curtis.
Hello.
Hello.
So can you hear me okay?
Yep.
Okay. So I built a kind of a time clock, like a punch in, punch out using a Raspberry Pi and an NFC scanner board. And here it is. So it's right here. So the idea is just tap the card.
Locking in.
Sign in.
Time to make some stuff.
That's it. And then it has an SQLite database file in the background, so it logs it, and then you can also put in like other cards for other people, and that's it.
Cool.
That's great.
And then of course the easiest of easy enclosures, just built out of cardboard.
Cardboard's in.
Yes, and that's the innards. Of course, it's using the Raspberry Pi 7-inch screen for the touch interface, and there's the interface board. I was just going to use the direct UART on the Raspberry Pi, but I kind of ran out of time, and this is a lot easier.
Yeah.
Good work. I've seen this project made and remade for like WeWork type co-working things for what Tech Shop was, and now it's Shop Build or something. So drop a note to support at Adafruit, and we'll send you as seen on the Show and Tell sticker. And if you want to put that up somewhere as a tutorial, you'll probably save a bunch of people a bunch of times, or it'll just be the next startup.
I actually have a YouTube video of its building up. It went up earlier today.
Okay, put that in the email for the sticker, and we'll post it up.
Sweet.
All right. Next up, we're going to go to JMK. JMK.
Hey, JMK.
What you doing?
Hello. So last time I was on, I showed my Arduino security thing, and I updated it so now multiple people can log in if they have their own passwords. So let's say I want to log in. I'll say my password will just be 1, 2, 3, 4, 5, 6, 7, 8, 9. And now it'll say Julian K is now logged in. New login for Julian K. And if I say 9, 8, 7, 6, 5, 4, 3, 2, 1, then example 1 will log in. And if I go 1, I don't know how many times I put in that 1, but now example 2. So it just logs in different people for different logins. And the next thing that I did is I wanted to just get more pins and make it so I didn't have to use a bunch of adapters and extension cables. So I switched my Arduino Nano for an Arduino Uno to just make things better. And I can take out the chip and debug it on a breadboard. And one other thing I'd like to mention before I get off is I got the Pi 3B Plus in the mail recently, which is great, and I was very happy because I wanted to put it in to my Pi Top, the laptop, which is the new one I just got, and replace the old Pi 3 that came in the mail with it, this one, with this, and I was very happy to do that. But the thing is, I did it has adhesive that is part thermal conductive material as the compound between the CPU and the heatsink. It didn't quite fit onto the slightly raised CPU middle part of the new Pi, so that was super annoying. And if I jerry-rigged the thing to make it go in, and then when I booted it up, it just had a red flashing light on the hub. So I'm really angry that Pi Top didn't prepare for this new Pi when they made their device, or that there isn't any blog post on their site that helps me with that, which is really annoying because now I'm gonna have to call them. So
they watch the show, so they might already know.
Great,
All right.
that'd be awesome.
Okay. All right. Well, thanks.
All right, thanks, JMK.
Drop us a note if you want a sticker as well. Okay.
All right,
We're going to keep getting through everyone. If everyone keeps it to just like a minute and a half minute, we can get to everybody tonight. Codingpro. Hello, Codingpro.
Hello. My Wi-Fi isn't working very well, but hopefully I can show you this. So I realized that I hadn't shown you the actual code for any of my bots so far. So that's kind of what I'm going to do today. Okay, so yeah, I've been working on a new bot, and this one basically holds data for me for my server. So it has like the variables, all these. It's coded in JavaScript with npm.js. So, but it's in it and with Discord IO, while JMKOS is using Discord.py. I'll show you what these different commands do really fast, so you can get to the next person. So, screen share. Okay, so on Discord, this bot basically keeps track of coins, so I can do SM daily and get my daily coins. And then I can, since I have a lot of money, because I gave myself a lot of money, I can do SM I custom role on show and tell. So basically, it takes out 1,500 of my coins, and now I have roll on show and tell.
Oh, cool.
Wow.
And then I can also buy like premium and some other roles too.
All right, initial coin bot offering.
Initial Codingpro offering. All right. Well,
All right, thanks
so
for
much,
the
Codingpro.
update. I love these bots you're working on.
Yeah.
Keep
These
hacking
are friendly
on them.
bots. These are nice bots.
These are friendly bots.
Okay. Next up, we're going to go to Sophie. Hello, Sophie.
Hey, Sophie.
Hi. So I have a new guide up about working with this conductive heater fabric. And it's just like a guide that shows some experiments and some things that I've been doing and different ways to connect to it. But what's cool about it is I've been using it with fabric that's been painted with heat reactive paint. So this is just cotton fabric, and it's got a pigment in the paint that I've painted on it that reacts when it is exposed to 82 degrees Fahrenheit. So if I just blow on it,
that's cool.
You can kind of like see it change. So I just thought I would show that because it looks really cool. So this is the fabric that I've got. I just used snaps. I just soldered my wires to snaps. And oh shoot, I just put it on my computer and it started heating up already. But you can kind of start to see it change.
That's cool. Yeah, you can see where the current's going in right there.
Yeah, you can see like it heats up definitely at the connection points, and then it kind of radiates out in the middle, and eventually it heats the whole thing. But it's just kind of neat to see it actually go. And this was a good way for me to just show in my guide, because I don't have like a heat mapping camera or anything, like where the heat was appearing in the material. So
it's such a common thing people want to do. That's really good. I mean, like people have their own creative ideas for like costumes or like interactive art that uses this. So it's good to have just like, here's a way of doing it. Because oftentimes people ask and it's like, well, you have to get these like thermochromic wires. It's such a pain. So this is way easier.
Yeah, this is way easier. So
this will be on the runway soon. You can imagine all the fashion applications where if it's not just next to you, heated up, it's like maybe on something else. You'll be able to control it and it'll change over time too.
Right, yeah.
Super cool.
Someone's like, I'm going to make a Rorschach mask like right away. That was like the first thing.
Like 3 people have said that already.
No, everyone had the same idea. Like,
no, everyone's like their own Watchman Club. That's why.
Yeah.
All right.
Yeah, Comic Book Girl 19 has Watchman Club, by the way. She has the subscription service. Check it out.
All right. Well, thanks, Sophie.
Okay. Next up, we're going to go to BlitzCity, and then we're going to go to Zach, and then we'll wrap up with Adam. So if we can get to everybody, we still can. Hello, BlitzCity.
Hey, Blitz.
Hey, how's it going?
Yo.
So I'm working on a video turntable right now for B-roll. So I'm using a continuous servo, and I just got to plug power in. I'm coding in CircuitPython, and I have a switch set up so I can reverse direction, and also have a potentiometer to adjust the speed.
Ooh.
and then I'm going to 3D print an enclosure so that the top can snap onto the top part of the servo, and then I can print like different colors if I want different colors for a video, and then there'll be like a little base with the controls. And I think I'm going to use the Itsy Bitsy for the board. But so yeah.
Yeah, Itsy Bitsy's making the rounds. A lot of people
Itsy Bitsy.
We're getting. It's nice when people use our product and they say like, "This is now my default go-to board." It's like, yay, we really did a good job with it. So
yeah, it's a great form factor.
All right, thanks so much, BlitzCity. If you want a sticker, you know how to get one.
Itsy Blitsy.
All right, next up, Zach. Hello, Zach.
Hello. Let me get into the shot here.
Yeah, what you got going on?
All right, so got a little burned out working on the glove, so I decided to move over to the main display and run a power test on it. So
You got some smoke going off there. Is that by design? You got some smoke right there. Is that okay?
Oh, I've got a stick of incense going.
Okay. No, I just wanted to make sure that way they wouldn't have like maker fire.
Not quite, but it's a risk.
All right.
So what you're looking at spread over my desk is just over half of the total LEDs that will be in the suit. And I've just got the simple test program running on them. Now, where did I set my phone? There it is. The biggest thing I'm doing here is that I am actually doing a temperature test on this.
Right.
So if I run over to my thermal program, a good shot there. So while that's all changing colors, I'll pull up my picture quick.
You know, the smoke is a nice effect with all this. You should keep it up.
Here we go.
Like
so I've actually got a thermal camera that plugs into my phone.
That's cool.
And this allows me to check the temperature of the wires. So far, I've found that when my system is running near top capacity, it's about 120 degrees Fahrenheit at the battery connection. And that's if I have both batteries plugged in. If I only have one, it starts to do dangerous things, and then I don't have smoke coming from incense. So that's about where I'm at on this one. It is running all of the power. Nothing seems to be overheating, so I'm happy about that. And I realized, too, I forgot the last time or the time before that I meant to do this for Thunder Snow Edition. So now if it'll connect, I don't have the Wi-Fi on.
Yeah. There we go.
There we are. Connect.
There's a lot of LEDs.
Yeah. Oh, there it is. Look at that. It's like Blink of the Snake.
There we are. Thunder Snow Edition.
Thunder Snow.
There we go.
All right. Thanks so much, Zach. We'll keep coming back, and if you want a sticker in progress, or you can save a sticker to the end of this project.
No, well, I've actually got one for it, so I'm waiting for the end on that. Yeah. And now that I have some lights to drive, next time I should have a functioning controller to see show what I can do with them.
Good stuff. All right, Adam, play us out.
Hello, can you hear me?
Yay, Adam.
Oh, perfect. So we're going to look at something a bit different today. Just a simple piece of copper wire that I bent a couple of times so it started to break open. But that actually leads to some very interesting results. So we got the wire here under the SEM. And you can see already some interesting details. This is a pretty low mag. Oh, real quick, I got my on-screen display working for the first time in a very long time. So I can actually see like how big things are and what magnification I'm at, which is amazing. But I don't have time to talk about that error or the fix for that today. So we'll zoom in a bit real quick. And you'll start to see some interesting details from the manufacturing process on this, namely these grooves over here. And so these grooves are actually from the machine that extruded this whole thing. The copper wires kind of forced through these dies, and it's cheap copper wires, so they don't need to make it really smooth, so the dies wear out and leaves these grooves eventually. But those grooves can lead to some interesting results. I'm going to do a quick stage move.
Boop, 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 boop.
Da, da, na, 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 na.
Yeah, this is my favorite Blade Runner scene.
Yeah.
This is totally like forensics. It's like, no.
This is exactly what I'm actually showing right now, is how you can use an SEM to do some metallurgical forensic works with.
Yeah.
Which is really a really important and very practical application for this thing. So we've got this kind of gouge over here. And this gouge is where I kind of bent it back and forth enough times so I was able to get it to start to kind of flex open. I just got to focus real quick. Focus.
Your
Enhance. Yeah, pretty
SEM's
much.
going really good today. It's in really good shape.
It's the best it's ever been. There is the most individual subsystems running that there has ever been running, which is kind of amazing. So
downhill from here. I'll make a super out of this.
Well, this is recording for posterity.
Yeah. So you can see this really interesting gouge here. But if we notice that on the top right side of this gouge, you can actually, once again, I got to do my quick stage move routine. on the top right side of this gouge, we can see that even though the wire is straight right here, we've got these deformations in the die marks on the wire. So that can actually tell you a lot of information like how it was bent. You can start to look kind of deep into the crack and you can see, okay, what direction did it open up in? Where do I see little strands pointing off into the middle of the air? And all these are different things that you can really only see with an SEM, but that tell you a lot of really, really interesting things about how this piece of metal failed. And so if you can think, like work that this machine's done before is, okay, we got this random piece of steel from a large hammer drill on a downtown pier in Seattle that just literally exploded when it got hit with the hammer, and it could have hurt somebody. So the manufacturer, or so the consumer or the person who's running the hardware came to the person on this microscope and said, okay, how can we figure out if this was built to spec or if this metal was to spec? And you can look at the crystalline structure of the metal and determine things like that. So it's some really interesting applications of this hardware that you can do by just looking at like, okay, kind of got some stretch marks here, therefore it broke in this way. Yeah. And you can look at this over the whole surface and see if it's uniform or all sorts of different crazy things like that. So it's a really cool application of SEM.
Cool.
This metallurgical work.
All right. Thank you so much, Adam. All right.
Yeah.
Well, tell for you. Got everybody in on time.
We have
Thank
like
you,
15 people.
Thank you, Sophie. Thank you,
Thanks,
JMK.
everybody.
Thank you, Ian. Thank you, Curtis.
Ian Curtis.
Thank you, thank you. Thank you, Codingpro. Thank you, BlitzCity. And we're here every single week.
Show and tell will tear us apart.
Yeah. Thank you so much. Thank you all the folks behind the scenes who help out, and thanks for making this the best Wednesday. Next week, Noe and Pedro are going to be running it. We're going to be away, so should be fine. So help them and support them and show your projects next week as well. We'll see everybody on Ask an Engineer in 2 minutes. Bye-bye.